Hi, my name is Wes Moir, and I'm a master's student at the University of Saskatchewan and a Weston Fellow Research Fellow for the 2025-2026 season. Importantly, I'd like to thank the First Nation of Nachonayakdun for helping to shape this project and supporting fieldwork within their traditional territory. This work would not be possible without their guidance and partnership. My research focuses on understanding freshwater health across central Yukon using benthic macroinvertebrates, or water bugs that live on the riverbed. A lot of freshwater monitoring relies on a simple idea. You compare disturbed sites to undisturbed sites, or reference sites, to gauge severity of disturbance. But in the Yukon, many reference sites are visited infrequently, sometimes with long gaps between sampling events. That raises an important question. Are historic reference samples still representative of what healthy looks like today? Or has baseline shifted over time? That question matters because central Yukon streams are exposed to multiple types of disturbance linked to hydroelectric generation, wildfires, as well as placer mining. Together, these disturbances influence water flow, sediment dynamics, as well as habitat structure. And with increasing mining activity and wildfire occurrence across central Yukon, we need better tools to diagnose the health of these freshwater ecosystems. Macroinvertebrates are well suited for this task because they are diverse, abundant, easy to catch, and they respond to different types of stress across the system over long periods of time. So, this past summer, I collected benthic macroinvertebrates from 28 watercourses across central Yukon in collaboration with the First Nation of Nachonayakdun. At each watercourse, we collected a range of data related to water quality, water flow, as well as habitat conditions. Next, we gathered bugs from the bottom of stream beds using a specialized kick net. Following collection, bugs were preserved and transported back to the lab for identification under the microscope. From there, I compare communities across time and between sites to answer two main questions. One, do reference sites appear relatively stable through time, suggesting historic reference data can be pooled with modern reference data? Or two, do disturbed sites show stronger shifts through time, consistent with greater disturbance or changing conditions? If we find historic reference communities still align with current reference communities, then historic sites can be used to strengthen our models and improve our ability to detect change. However, if they don't, then pooling historic reference sites with current ones could blur the benchmark and weaken our assessments. Either way, this work will help us understand how heavily we can rely on past data to support present-day freshwater decision-making. Support from the Weston Fellow Research Fellowship helped cover the cost of fieldwork in the north, and it also supported engagement with communities and partners, so the work stayed grounded in regional conservation priorities. Thank you to everyone who made this research possible, including the Weston Fellow Research Fellowship, a program of Wildlife Conservation Society Canada, which is funded by the Weston Family Foundation.